Let's practice the tool I just showed you for integrating over rectangles. Remember the setup is this. If you're integrating over a rectangle, which means that all bounds are constants, and the integrand can be factored as a function of x multiplied by a function of y, then it's going to be possible to break the integral down into the product of two integrals, one with respect to x and the other with respect to y. Let's see if that tool works here. I'm going to integrate x from 0 to 4, y from 2 to 6, the function xy plus y. One thing to notice is all four bounds are constants, so we are integrating over a rectangle. Also, notice that the integrand xy plus y can be factored as y times x plus 1. In other words, a function of x multiplied by a function of y. So does this tool work here? Yes, it does. This is a great example. So let's break this down. I can break this down as the integral of a function with respect to x multiplied by an integral with respect to y. I'll factor out the x plus 1 into the x integral and the y into the y integral. Notice that y goes from 2 to 6 and x goes from 0 to 4. So let's carry out the two integrals separately and then multiply their answers. Integrating x plus 1 with respect to x, I get a half x squared plus x, and that'll be taken from 0 to 4, multiplied by the integral of y is a half y squared, and that's taken from y equals 2 to y equals 6. So I have 1/2 of 16 plus 4 minus 0, multiplied by half of 36 minus half of 4. So 8 and 4 is 12 times 18 minus 2 is 16. So the answer is 12 times 16. $196. Now, let's look at some more examples. Let's see if the tool applies in this case. Integral 2 to 5, integral 1 to 4, x plus y, dy dx. Well, all four bounds are constants, so we are integrating over a rectangle. However, notice that the integrand can't be factored as the product of a function of x multiplied by a function of y. Here I have the sum of x and y, but I can't break it down as a function of x multiplied by a function of y. So the shortcut doesn't work here. You're going to have to integrate this one the slower way. First, integrating with respect to y, treating the x's as constants, plug in the bounds for y and subtract, and then integrate the result with respect to x. One more example. Will the trick or shortcut work this time? Integral from 0 to 2 pi, integral from 1 to 2 of x times the square root of x cubed plus 1 sine y dx dy. Well, let's look at it. First of all four bounds are constants, which means that we are integrating over a rectangle. Also notice that the integrand is the product of a function of x multiplied by a function of y. So that means that this can be broken up. We can write this as the product of the integral of x x times the square root of x cubed plus 1 dx, taken from 1 to 2, multiplied by the integral from 0 to 2 pi of sine y dy. Now, something you might notice is that if we integrate sine y from 0 to 2 pi, then that integral is going to equal 0. And this integral, whatever it comes out to be, and it's not going to be any fun to actually carry out the integral, when you get the answer and multiply by 0, you'll get 0. Later in the course, especially when we're working with trig functions, we're going to find it useful if we can factor out the integrand in this way and carry out the integral piece by piece.